Hey Matrix, welcome to the next video in the chemistry playlist. Today we're covering question 9 of the November 2020 past paper. If you don't have the paper, there's a link in the description down below where you can get the paper as well as the memo, and then we can continue with the video. Okay, let's get started with question 9. Okay, so question 9 is talking about a simplified diagram representing the electrolytic cell used to electroplate copper coin with silver. Okay, so I've indicated here that the positive side, or the positive terminal, is my anode and the negative terminal is my cathode. Okay, so silver is on my anode and the copper coin is on my cathode. Okay, now 9.1 says define the term electrolysis. Okay, so that's one of your definitions, which you guys can go and look up in your definition list. Okay, and write it down for word. I'm going to be starting with 9.2. So it says which component in the diagram indicates that this is an electrolytic cell. Okay, so the hint I've given you here is where is the voltage coming from? Okay, so is the cell providing the voltage, or have we added a voltage source? Okay, so we can see that we've added a battery in order to put power into this system. Okay, so therefore we've supplied the battery, therefore it's an electrolytic cell. Okay, so the hint that this is an electrolytic cell is the battery. Okay. Now, looking at 9.3, 9.3 says write down the name or formula for the electrolyte. Okay, now you need to note that the anode is where oxidation takes place, and we know that from our little saying oil rig, we know that oxidation is loss of electrons and reduction is gain of electrons. So we know that oxidation is happening here on the silver electrode and it's losing electrons. Okay, so we know that the electrolyte needs to have something with silver in it. Okay, now there are quite a few that you would have had to study for this kind of cell, but the most common one used is silver nitrate. Okay, the formula for that is AgNO3. Okay, there are others such as silver ethanoate or silver fluoride. Okay, silver nitrate is normally one of the easier ones to remember. Okay, now 9.4 says how will the concentration of the electrolyte change during the electroplating? Will it increase, decrease, or remain the same? Now note that when we deal with circuits over here, the electrolyte is completing the circuit to allow electrons to flow. So as this decomposes into the solution, so does the silver in the electrolyte attach itself to the copper coin. Okay, so because the flow, we look at it as being constant, we know that as this breaks down, this starts to plate, because without any silver in solution, this won't plate with silver. So we can say that the concentration remains the same. This is why we have the silver electrode, so that it keeps the concentration the same, due to the oxidation reaction is equal to the reduction reaction. Okay, so 9.4, we can then say it remains the same. Okay, this is due to the oxidation reaction. Reaction rate equal to the reduction reaction rate. Okay, because as this breaks down into solution, so does the silver then plate itself to the copper. Okay. Finally, the last question says write down the balanced equation for the half reaction that takes place at the silver electrode. Okay, so we've identified that the silver electrode is my anode, okay, and we know that oxidation takes place at my anode, and oxidation is the loss of electrons. Okay, so we're losing electrons over here because this is decomposing into solution. So if we go to our standard reduction table, okay, remember we're dealing with table 4b. If we find where Ag is, we can see it's right down here at the bottom. Okay, and we can see that it's Ag plus an electron goes to Ag, but we're going to write the reverse of this as you see it on the table, so from right to left, as we're going from Ag and we're breaking up because it's losing electrons. Okay, so if we write the half cell reaction for that, it's going to be Ag, okay, is then going to go to Ag plus into solution plus an electron because it's losing electrons. Note that the arrow points in one direction because it's not a reversible reaction here. Why? Because the Ag, or the silver, is breaking down into solution. Okay, and that's how we go. Okay, if you found today's video helpful, then please leave a thumbs up on the video. It does help me a lot. Please consider subscribing to the channel as well. If you have any comments or questions, leave them down in the comment section below and I'll get back to them as soon as I can. And remember, it's never too late to have an OIC moment.